Okay, right. So today I'm going to talk to you about giant Triton snail, and in particular some of the biology and ecology. But I love this video. This video shows the true challenge that we face with the crown of thorns starfish. And in fact, it also highlights Uzo's frustration that he was talking about yesterday. Unfortunately, the current control methods are simply not designed to target cryptic cots. And we need to start to think beyond just manual injection as a form of control, especially if we're talking, many, many decades in the future. Fake news. So those of you who attended the meet and greet last night, and Warren Inch got up and started talking about fake news, and everyone's eyes started to roll. And I thought, hold on, he might be onto something here. So fake news is the use of a non-fact or a false piece of information, or of a real piece of information but out of context. And it's designed to change our beliefs and modify our behaviours. And so it got me thinking last night, after a few champagnes, that perhaps this is how I should be selling the story of the giant Triton snail. So what we would like to do is take a false piece of information, provide it to the crown of thorns starfish to alter its behaviour. And if we could do this in the short term, and then perhaps also modify it to make it a long-term solution. And as you do, you start to go down a bit of a rabbit hole, and I got a bit excited and I was trying to find the magic bullet that would cull Cots all at once. And then I opened up my email and this picture popped up from Dan and his crew. And I realised that the Great Barrier Reef actually already has its own weapon of mass destruction. Welcome the giant Triton. And yes, sadly, Cots were harmed in this photo. Yep. So if we're going to deliver fake news to Cots to try and control them, we first need to understand how they're actually sensing this news. How are they actually interacting with their environment? So we undertook a review into the chemosensory capacity of asteroids, with a particular focus trying to look at the traits that might be relevant to crown of thorns starfish. And we know, for example, that they contain very potent toxins on their spines and on their, the outer layer of their skin to deter predators. We know that they're attracted to their coral prey, and that their coral prey contains chemistry that actually extrudes their stomach and enables them to consume copious amounts of coral tissue. We also know that they release their gametes in a synchronised manner, and that there's likely a conspecific cue that is emitted by the males to encourage the females to spawn. So a lot of these traits were actually also found in Cots, but what we didn't find much information about was how they're actually detecting this chemistry, how are they actually responding. We looked into the sea urchin literature, and what we found was that the sensory tentacles seem to be a source of chemoreception. So we secured some funding through the Caring for Country program, and we started to investigate the chemosensory capacity of the crown of thorns starfish. The first part of this project was to sequence the Cots genome. With the genome in hand, we then can start to look into the genetic makeup of Cots to look for genes that might have function as chemoreceptors. And we know these kinds of genes from the insect world. So what we identified was a number of candidate rhododopsin-like G-protein coupled receptors. And so we undertook some in situ hybridisation and some immunofluorescence staining, and we were able to show that these particular genes were actually located at the interface between the tissue of the sensory tentacle and the external environment. So now we know how they're listening to their news. But fake news relies on two things. It's highly emotive, and it's usually based on fear. So we thought, well, in the Cots world, what kind of signal, what kind of fake news could we deliver that would encourage this fear response? And in the animal world, it's usually the predator that does that. So we started to look into the literature about predators of crown of thorns starfish, and we came across the giant Triton snail. So the giant Triton snail is a benthic creature. It lives within the same substrate, the same reef substrate as crown of thorns starfish. We believe it's nocturnal, and it's definitely cryptic. So it actually has a lot of the traits of the prey item. So this we thought might be a good target to start with. So we approached Gbrmpa, and they provided us with a permit to start working with the giant Triton snails. We designed a Y-maze assay, and here we see 2 cots placed in the arms. One is going to be exposed to controlled seawater, and the other one to the giant Triton snail scent. And what we found is that the control animals barely moved out of the arm, and when they did start to venture out, they hit the plume and then didn't go any further. Whereas those that were exposed to the giant Triton scent not only moved out of the arm and into the leg of the Y, some of them actually then sought refuge in the control arm. So it's a very clear escape response. And here's an example. We see the water just being introduced now, and the cot suddenly takes off, and in some instances they literally try to flip themselves onto the surface of the water. So it's quite a dramatic escape response. So we know that they are listening in on their Triton predators. But gastropods, like crown of thorns starfish that Jason was talking about earlier, shed a lot. They have a mucus trail, and their shells actually shed a lot of protein. So we thought, well, perhaps they might actually be confusing signals with things like the spider conch. So the spider conch is also a large gastropod that lives on the Great Barrier Reef. It's a grazer, so it's not a predator. And what we found is that in response to the presence of a spider conch, the crown of thorns starfish behaviour did not change. They still had this general meandering behaviour, which was the same as what we saw with the control cots. So what we're showing here is that the crown of thorns starfish is absolutely listening into its predator, and it's selectively listening into its predator. So this suggests that the predator cue that's being given off could actually be a useful signal for us to start to exploit. So it occurred to us at the same time that we knew nothing about giant Triton biology. And if we consider the idea of using a chemical cue as an alarm cue for the crown of thorns starfish, we want to make sure that the cue that we're using is a cue that's going to elicit the same fear response over and over again, i.e. it's going to be very, very potent and very effective. So we decided that we really needed to understand a little bit more about the giant Triton, and we conducted a reciprocal Y-maze assay where we exposed the giant Triton to the scent of either controlled seawater or crown of thorns starfish. And you can see from the heat map that there was a pretty clear direction of seeking behaviour, going up into the arm that had the cue. So this showed that the giant Triton is listening in on the cots in reverse. We also then looked at some observational videos. Well, what you can see here is the proboscis is actually stabbing, if you like, into the central disc of the crown of thorns starfish. The giant Triton contains very acidic saliva and, we believe, a series of toxins. It also exudes this mucus over the top of the crown of thorns starfish, and it has a radula-like tooth that it then uses to cut the crown of thorns starfish into pieces. So based on this information, we then undertook a transcriptomic analysis of the salivary gland of the giant Triton snail, and what we found were some candidate proteins that were reminiscent of proteins found in spider and snake venom. So what we've now convinced ourselves is that we actually have a true predator of the crown of thorns starfish. It is able to actively seek and hunt. It is able to actively immobilise and kill. And that's what we want for our source for our fake news signal. Oh, gone one too far. So as I said, we still didn't really understand a lot about the biology of the giant Triton. So we undertook a review within the NEST program, and we came up with 2 major knowledge gaps. The first was that there's a lot of anecdotal evidence that the giant Triton snail has been overfished and that its populations haven't recovered. So one recommendation was to see whether we could close the life cycle of the giant Triton snail, with the idea that one day we could perhaps restock their numbers on the reef. The second was that we didn't really understand how they even interacted in their environment, and if we don't have that knowledge, then we won't have the knowledge, we won't know how they interact with Cots in their environment. So we secured some funding through the Reef 2050 Sustainability Plan to basically try and do these two projects. Now, I'm not going to talk to you today about the rearing, other than to show you how cute they are when they're babies. If you want to know more about that, please come and see me afterwards. I'm more than happy to talk to you about it. But today I'm going to talk to you about the acoustic tagging side of the work that we did. So we found a site at Rib Reef. We're particularly interested in a fairly secluded site that we could easily deploy a listening array and then deploy our animals within that over a period of about 40 days. The animals, because they're vulnerable species, we can't have a permanent tag, so we designed this semi-permanent system where the signal emitter is basically got a silicon sleeve that slides over the end of the shell spire. We had 5 individuals that were collected by several groups for us off Rib Reef, and all of these animals were deployed back onto Rib Reef. So they were deployed during the summer. The summer coincides with when they are most hungry and when they're just starting to mate. I'm just going to show the example of 2 of the animals, the trajectories. And what we see here is that, so we deployed them all around this particular bommy, and the bommy sits in the middle of our listening array. So we assumed that they would all go to the bommy, and we were really hoping that they would start to interact with each other because it is breeding season as well. We might start to get some information about how they interact with each other within the field. But they did almost exactly the opposite of what we predicted. They all moved directly away from the bommy over the 40-day period, and in the end, 4 out of the 5 animals actually left the listening array. This was surprising to us, but one way to interpret the data is that they're actually all going in a southward direction, and that happens to be against the general current known that's been reported previously. So are they actually listening in to the chemistry that's coming off the reef? Are they listening into where their prey may be? Are they seeking a safe refuge? We don't know the answers to these questions, but we're starting to now get some insight into how they interact with their environment. So we were able to look into this data a little bit more. These 2 data sets are split into a day and night time, and the different colours represent the 5 different individuals. And what we're able to see is that during the daytime, the trajectories were relatively straight and quite reminiscent of refuge seeking, whereas at night time they tended to show concentric movement, and this is more reminiscent of foraging and hunting. We also found that they moved twice as much during the night as they did during the day, and this confirmed that they're most likely nocturnal animals, very similar to their Cots prey. We also were able to calculate the average total distance travelled by giant Tritons, and that was around about 234 metres per day. Now, if we remember from Morgan's talk this morning, Cots don't move very far, and in fact, Keesing and Lucas back in 1992 reported that they move 10 metres a day when they're starving and looking for food. So what we've been able to show is that the home range of the giant Triton snail is well and truly beyond that of the Cots prey. So in theory, if we restock the numbers, bring the populations back up, then perhaps we might actually have an army that could control crown of thorns starfish into the future. So what does this have to do with stopping the Cots roundabout? So we know that we're currently in the termination phase and likely going into a non-outbreak phase. And this is the peak time where a control agent such as the giant Triton snail could come into its own. The giant Triton snail doesn't eat very much very often, but when it does, it's a voracious eater. So if we could deploy giant Triton snails during this period of time on the reefs, while population numbers are down, we might have a chance to actually suppress them into the future. We may possibly be able to stop the initiation or delay the initiation if we're also able to use this concept of fake news. So we might be able to use the actual presence of the animal and a chemical cue that's giving it, the crown thorn starfish, a false signal, and together we may be able to, in the future, suppress Cots populations. And that just leaves me, I'm having trouble with the clicker, to say thank you very much to all the people that have helped in this research over the past 6 years, and in particular to all the people who've gone out and collected Cots to keep our giant Tritons happy and well fed. And thank you for listening.